So as I said, lesson 2, definitely more just algebra topics here. So we'll see what you guys remember about. Honestly, a lot of it is algebra 1. I'm trying to remember what's on the back side of my notes. And we get to review the graphing calculator teensy bit. So, okay. Example 2-1, guys. Find the coordinates of the point halfway between -4,7 and 13,5. There's a formula for this. We're trying to find the point halfway between. We're trying to find the midpoint. Okay. We had a midpoint formula. Do you remember how to find the midpoint? If you're trying to find the midpoint of two ordered pairs, you're trying to find an ordered pair. And so it's usually written as x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Basically, you add the x's, divide by 2, because you're finding the average. Add the y's, divide by 2. Is that easy enough? This is even before algebra, honestly. I feel like I've taught that in like 6th, 7th grade math type stuff. Oh yeah, it would have popped up in review probably at some point last year. Okay, so, did you do this one? What are you doing? Tell me the math.
So you're doing -4 plus 13 divided by 2.
Okay.
7 plus 5 divided by 2.
Okay. -4 plus 13 divided by 2, 7 plus 5 divided by 2. Yes, I'm showing the work, okay? So do what you do in your notes. I don't care, but I'm showing the step. -4 plus 13 is 9. 9 divided by 2 in my book is 9/2. You can say 4.5, 4.5. Well, we don't usually do a lot with mixed numbers, but you could say 4.5. 7 plus 5 divided by 2? 12 divided by 2 is 6. So I would leave this answer as 9/2, comma 6. 4.5, comma 6 is acceptable also. Okay. Find the distance between 4, 3 and -2, -2. There is also a formula. Yes, it does have a square root. This is, it's one big bad square root. This time it's x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and that is all under one big square root. It at least sounds familiar, right?
Yeah, I loved this one.
Whether you could come up with it off the top of your head that exact moment on your 3rd day back to school this year is a different story. But on the 4th day of school, you'll be able to come up with it now, right? Hopefully. Abby had that look like, oh, maybe I'll remember this. Okay. Officially, it doesn't really matter which is your 2 and which is your 1. Just be consistent. I tend to like to put my positives first, but that's me. So if I do this, I would probably do the square root of 4 minus -2 quantity squared plus 3 minus -2 quantity squared. And that's all under a square root. 4 minus -2 is 6. 3 minus -2 is 5. So then I'm doing 6 squared plus 5 squared. If you put the -2's first, you're doing -6 squared and -5 squared, right? So either way, it's going to work out to be the same, because I'm going to have 36 plus 25, which is 61. So the non-calculator answer is the square root of 61, which is what I'm leaving it as. Obviously, if they said round your answer to the nearest tenth or nearest hundredth or something, you'd want the decimal form. Okay, moving along. Definitely talking algebra now. Use the point-slope form of the equation of a line to write the slope-intercept form of the equation of the line that passes through -2, 4 and has a slope of -2/3. Man, they just threw words at us. Point-slope form. You left out an important piece. Yep. Point slope is y minus y1 equals m times x minus x1. It uses a point and a slope. Okay, so we're going to be starting with that. And then our job is to get it to slope-intercept form. So while I'm writing down information, what is slope-intercept form? Yeah, that's the one that should come easier. Y equals mx plus b. And I'm writing all these formulas and stuff down just so you have a place to reference, right? Give it a couple days, they'll be stuck in your head, you'll be fine. So it said to use the point-slope form. So we're going to start with point-slope form. So I'm going to write up here y minus y1 equals m times x minus x1. And what do we know here? And we know our point and a slope. This -2, 4, they're going to go in place of x1 and y1. The slope is going to go in place of m. So y minus 4 equals -2/3 times x minus -2. But we all know x minus -2 is really x plus 2. Okay. Officially, it says then to go for slope-intercept form, which really just means we have to solve this equation for y. So I see 2 steps that need done. What are those 2 steps? Okay, add 4 and distribute, yes? I'm going to go ahead and distribute first. If we distribute, -2/3 times x is -2/3 x. -2/3 times 2. 2 as a fraction is 2 over 1. 2 over 3 times 2 over 1 is 4/3. And there's a negative times a positive, so -2/3 x minus 4/3. Since it's y minus 4, I am going to add 4. So then I'm going to have y equals -2/3 x plus 4, or -4/3 plus 4. How do we add 4 when we're adding it to a fraction that has a denominator of 3? Yeah, we want, you're going to multiply that 4 by 3 over 3, aren't you? So it's going to be 12/3. Are we okay with that? So -4/3 plus 12/3 is going to be 8/3. I cannot stress enough, guys. This is definitely a non-calculator problem here, okay? Half your AP test, and I know it's early, but I'm going to start talking about AP test from the beginning. Half your AP test is non-calculator, okay? Don't rely on your calculator to do all the fraction jazz and stuff, okay? Start now brushing up your fraction by hand work, and that's what you'll see me do a lot when I'm teaching. I'm not going to grab to the calculator and something like that. So you can still check yourself, but start brushing up your basic math skills now. We good there? Okay. Write the slope-intercept form of the equation. So we already talked about slope-intercept form of the line through -4, 2 that is perpendicular to -2x plus 3y plus 1. So slope-intercept form through -4, 2 and perpendicular. Well, yep. Okay, so first of all, important to recall, lines that are perpendicular, their slopes are what we call opposite reciprocals. So I'm writing that down. Perpendicular slopes are opposite reciprocals. Opposite meaning positive instead of negative or negative instead of positive. Reciprocal meaning flip the fraction upside down. So to start this problem, what should we probably do? Yeah, we need to find the slope of this line, don't we? Looking at that, I don't know the slope. Easiest way to find the slope is to solve for y here and put it in that y equals mx plus b form. So I personally like my positive 3y. So I'm going to keep my 3y on the left, which means I'm going to add 2x and subtract 1 over to the right. And then I'm going to divide by 3. And I have y is 2/3 x minus 1/3. So what's the slope of the given line? 2/3. What would be the parallel slope? I threw a trick in there, yes, okay. The parallel, just to throw it out there, parallel lines have the same slope. So parallel would be 2/3. However, we were asked for perpendicular slope, and the perpendicular slope is negative 3/2. Are you familiar with this upside down T meaning perpendicular? That upside down T is an official perpendicular meaning. I wrote the P or P in there too, but okay. So we're using this negative 3/2. We're using the negative 4/2. My job is to write this line in slope-intercept form. My preference is to start in point slope. I don't like trying to find the b by using y equals mx plus b. That's a personal choice, but that's been one of the techniques you've learned over the years. I prefer to start in point slope form. So I'd prefer to say y minus the y value of 2 equals the slope, which is negative 3/2, times x minus the x value, so x minus negative 4. I'm going to distribute. Y minus 2 is negative 3/2 x. Minus times plus is going to make it minus 3/2 times 4. 6. I cross-canceled the 2 and the 4 in my brain, and that became 3 times 2. Or 3 times 4 is 12, divide by 2. Add the 2 over, and y equals negative 3/2 x minus 4. Please ask if you have questions, okay? If I overlook something or go through something, we just need that reminder. Please ask. Otherwise, I'm trying to just keep us moving because hopefully, if you chose to take calculus, some of this stuff comes back pretty easily. That's my hope. Ready for the next example? Solve by completing the square. It doesn't go away. It still randomly pops up in our life. So, we do need to review completing the square. In order to complete the square, I don't know how much you guys remember, if anything. I always think of it, when we go to complete the square, you can't see what I wrote. You always want to get x squared plus bx. And specifically, what has to be in front of x squared? A 1. You always want to get 1x squared plus bx. In this situation, since we're solving an equation, I'm going to make it 1x squared plus bx, and I'm going to put my number then over on the right side. So I'm trying to get x squared plus bx by itself equal to a number. And then, yes, Ross does remember, b over 2 quantity squared is what we're going to find and then add to both sides, if you will. So with our particular problem, I'm going to keep the x squared minus 3x. I like to leave a blank. And then I'm going to take the plus 1 and subtract it, so we have a negative 1 on the right. So x squared minus 3x equals negative 1. Okay, what's b? Negative 3. What are we doing with negative 3? Dividing it by 2 and squaring it. So for me, negative 3 divided by 2 is negative 3/2. Squared is 9/4. That means I'm going to complete the square, I have to add 9/4 to my x squared minus 3x. If I add 9/4 on the left, add 9/4 on the right. The whole point of completing the square always is that I can now factor it into a perfect square. That's always, anytime you complete the square, your next step is going to be, oh, okay, now this factors into a perfect square. Remember, x squared breaks into, officially, x times x. I just write 1 because I just write the 1 parenthesis. Do you remember how to get the number? You can look at it as the square root of 9/4, or it's what did we square to get 9/4, which was 3/2. Specifically, it was a negative 3/2, and we know that because it's a negative 3x here. So that factors into x minus 3/2 squared. On the right, what is negative 1 plus 9/4? Negative 4/4 plus 9/4 is 5/4. Do you remember how to solve? Take the square root of both sides, right? It always factors into a perfect square, and because it factored into a perfect square, we want to take the square root. Square root of x minus 3/2 quantity squared. X minus 3/2. Square root of 5/4. Okay. Square root of 5 has to stay square root of 5. Square root of 4 can become 2. And don't forget, because we took the square root in an equation situation, plus or minus. So x minus 3/2 equals plus or minus the square root of 5 over 2. If I solve for x, since it's x minus 3/2, we're going to add 3/2. And so I'm going to write my answer as x equals 3/2 plus or minus the square root of 5 over 2. I taught it in Algebra 2. We used it in pre-calc, and it's here to stay in calc. Did that come back to you some, though? Hopefully, going through pre-cal, you should have gotten a good grasp of it. So, okay, here's another favorite. Actually, some of you do like this one. Some of you hate it. So, okay, quadratic formula. Do you remember your quadratic formula?
I remember the German guy who sang it.
Hey, and I had people last year that actually told me, they're like, that's, I think it was some of my calc kids, they're like, that's how I remember it. I'm like, you know, I don't care as long as you know it. Again, is this something, if you have to use a quadratic formula on AP calculus test, which you possibly could, are they going to provide it? No. Okay, you have to know that. So, negative b plus or minus the square root of b squared minus 4a 2a. And what has to be true before we start the quadratic formula? What has to be true of our equation? Has to equal 0. If it doesn't equal 0, you got to make it equal 0 first. Okay, so x equals negative b 3 plus or minus the square root b squared, so negative 3 squared minus 4 times A, which appears to be 1, times C, which appears to be 1, all over 2A, which is 2 times 1. Clean it up. 3 plus or minus the square root of, 3 squared minus 4, so 9 minus 4 is 5, all over 2. And on a problem like this, that's probably how you can leave it, unless they want decimal answers. So 3 plus or minus the square root of 5, all over 2. Anyone notice anything about those last two problems? They were the same.
And yeah, that's equivalent. You do 3 over 2 plus or minus 2.
Example 5 and 6, completing the square quadratic formula. You did this 2 different processes, same problem, same answer, just looks different, doesn't it? Okay. Okay, the back side gets a little bit, I don't know. This could fall into Algebra 2. You know, a lot of the rest of our day has fallen into Algebra 1 so far, which has been nice. This could fall into Algebra 2. Now, here's the deal. I didn't get to teach something yesterday about factoring. Did any of you guys come across the, I think you would have had to in homework, factor a perfect trinomial? Okay, so the easy version of factoring a perfect trinomial would be factoring something like x cubed minus 8.
Oh, yeah.
Where it factors into a binomial and a trinomial. Does this ring some bells? I'm not saying you remember it, because this is something I should have taught yesterday. I ran out of time. And I'll write a formula down for you, but the cube root of x cubed is x. The cube root of 8 is 2. Keep the middle sign. This is a trinomial. For the first term, you square this. For the middle term, you multiply these two together and use the opposite sign. And for the last term, you square this.
What do you do for the middle one?
The middle term, it's multiplying these two together and using the opposite sign.
Okay.
Okay? And I kind of have, last year I wrote it down as a formula at some point for you, right? Actually, last 2 years, because I think I taught in Algebra 2. Again, I would have done this yesterday, but time. So, if I have it written here as using f and s. So, if I say f cubed minus s cubed, f being the first, s being the second, I think maybe that's what the calculus book uses. Use x and y if you prefer. But that factors into f minus s, so that's the cube roots, right? And then it factors into f squared plus fs plus s squared. That sounds a little familiar, right? I'm not sure I used f and s in the past, though. That might be what the calculus book uses. But I can also, just the same, say f cubed plus s cubed. And then that factors into f plus s. And f squared minus fs plus s squared. With some practice, those will stick. Okay, with some practice, those will stick. It just, practice. Now, I bring that up because we can use that factoring on example 7 here. Or if you prefer, we could do long division. I don't know about you guys, but I think I'd rather factor it. So I am going to write over here, or long division. We're not going to use long division, but with that in mind. So when it says divide x cubed minus y cubed by x minus y, realize division can be expressed as a fraction, right? X cubed minus y cubed over x minus y. Okay. Thank you. Does help if I put the full screen up there. There we go. Better? Okay, so I just wrote a note over here, or long division, just like this problem could be done with long division. We wouldn't want to do it, but we could. Division says to divide those two, so I set it up as a fraction. One of our techniques is to factor and look for factors that cancel then. Can you factor x cubed minus y cubed using the technique I just reminded you of? X cubed is a perfect cube. Y cubed is a perfect cube. So here's your opportunity to try. Cube root of x cubed, x. Keep the middle sign. Cube root of y cubed, y. Oh, that just kind of happens to match something on the bottom, doesn't it? Okay. Trinomial. The first term, you square your first root over there, so x squared. The middle term, multiply the two cube roots and use the opposite sign. So I'm going to say plus xy. And the last one, you're squaring that. And the whole point of that is x minus y can cancel, and you're left with x squared plus xy plus y squared.
The main one on the homework last night was one where it was like the three system of equations, like three equations.
Okay.
And I think I did it correctly because I remember like you had to make new equations and all that stuff.
What'd you get?
I forget what I got. Those probably
I got.
I don't remember which one was on there, so we'll look at it here a bit. Okay, example 8 here. X squared plus y squared equals 9, y minus x equals 0. It says solve. Gives me no direction other than solve. Thoughts?
So we just.
Okay, so we can look at the fact here that if you solve this for y equals x, right? So that means the top equation, I don't know, what mood are you in? Do you want to work with y's or x's? Either take your y and replace it with x, or take your x and replace it with y. I'm going to go with x's. So I'm going to say x squared plus, instead of y squared, if I replace y with x, it's going to be x squared equals 9. X squared plus x squared is 2x squared. So 2x squared equals 9. To solve for x squared, I divided by 2. So I'm at the point of x squared equals 9 halves. What do you know? Yes? Yes. Okay, so before I move on to that rationalization step, what hasn't been mentioned? Plus minus. We took the square root in an equation setting, so there's officially 2 possible roots. And then if we rationalize as we should, multiplying by square root of 2. And so then officially our x value is plus or minus 3 square root of 2 over 2. So that's my x's. It just said solve. It's a system of equations. I'm trying to hint to the fact that we're not done. Yeah, these are the x's. What do we need in a system of equations? We need y's, right? We need ordered pairs. So what I know right now is that one of my ordered pairs is 3 square root of 2 over 2, comma something. My other ordered pair is negative 3 square root of 2 over 2, comma something. So the point is I have 2 ordered pairs as my answer. What do you know about those y values? How do we find them? plug it back in. But the easiest place to plug it back in, y equals x. Oh wow, that just made life really easy. So, when it's 3 square root of 2 over 2, y is 3 square root of 2 over 2. When x is negative, y is negative. Can you visualize what y equals x is as a graph?
That's just like the straight.
Y equals x is that perfect diagonal line that goes through 0, 0, slope of 1, yes? Okay, here's the trickier question. Do you know what x squared plus y squared equals 9 is?
Well, would have to be the same.
No. X squared plus y squared equals 9 is a circle
Oh, yeah. 'Cause
centered at the origin, because there's no plus or minus on these,
I remember that.
with a radius of 3. Does that sound familiar? Okay.
We can
So,
get into like circles and parallels and all that.
we don't really get into them. We just randomly use them. You're supposed to already know them all. Okay, so x squared plus y squared equals 9. That's just saying it's a circle centered at the origin, radius, which is the square root of this, so 3. So does that make sense why there's 2 answers? You've got a circle with a line crossing through it. Yep. And if you're graphing this, though, if we would have solved this by graphing, we would have had to have 2 equations for the circle, a top half and a bottom half. Okay, officially 2B says the graphing calculator. This is very much review of how do we use a graphing calculator. It's sat all summer and I have no idea what to do. So, use the graphing calculator to find the zeros. What do we mean zeros? Okay, so zeros are any place it crosses the x-axis. So, grab the calculators, try them. Okay, remember how to go to y equals? I don't know how much I need to remember. X is next to the alpha button, so it's x squared minus 3x plus 1. I like to do zoom and 6 to get me a standard zooming window. Is this coming back to you easily or not easily? I know that's...
I want to hold someone down.
Yeah. So y equals, when you type it in, remember x, the variable is right here next to the alpha. And then you can either hit graph, or I like to, not knowing what I graphed last, I like to go into zoom and go use Z standard, which is number 6. Okay. Do you get to guess at those zeros? Okay. I like to go second, and then right above the trace button is calc. So second and the trace button. And number 2 is zeros, right? So you hit 0, and it asks you questions. It asks you for a left bound. So I just want to make sure that I am left of the first 0, so left of the first x-intercept. Hit enter. Then it wants right bound. So now I'm going to be to the right of that. Then it says guess, which as long as you have 1 in there only, it's fine. Hit enter. Is one of your zeros 0.38196601? Okay. Saxon math book is always going to go 4 decimal places. You need to get in that habit. AP requires 3. So I'll let you slide if you go 3. If you go less than 3, I can't let you slide. Okay? So I'm going to teach that from day 1. I guess it's day 2, but first time we're talking decimals. Minimum 3 decimal places. Saxon for everything. Saxon's going to go 4. Okay, so this book's going to go 4, but 3 is your minimum. And that 3 would be fine on the AP Calc test. Okay, so you use second trace or second calc, however you think about it. And then you went to zeros, which is in your menu. 1 one of your answers, 0. If I go 3 decimal places, that's 3820, right? If you round it appropriately. Did you get your other one? Yeah, something like that. We do second calc 0, left bound, right bound, guess. Yeah, 2.618034, which I have rounded to 2.6180. Okay, coming back to you, right? Of the graphs of the functions. So you have to go to y equals and you have to graph it again, yes? Good news is don't delete the one you just had, right? y1 can stay the same. y2 is x plus 1. Again, I'm going to do zoom 6. Okay. What's the more effective or more official way than just eyeballing it? Yeah, same menu from last time, that second trace or second calc. Go down to number 5, which is intersect. I don't know how much we use this one, though, so let's make sure we know how to use it. Hit enter. It's asking first curve. So right now, for me, y1 is showing up here, and my cursor is on the blue curve, my parabola. So that's my first curve. Then I'm going to hit enter because one of the curves is selected. Now it's saying second curve. So this would be like if you have 5 curves on your graph, which curve do you want to use? Okay. Now it automatically defaults to second curve, which is y2, and that's what I want to use, right? So I'm going to hit enter. A guess. There's 2 different intersects, right? You have to move the guess for one of them. Right now, it's sitting about where that first intersection point is. So I'm going to hit enter. What's it tell me the intersection point is? 0, 1. Okay, so you've got one of your intersection points. Repeat the process to find the other one, except when you find the second one, you have to move at the guess. Does that make sense? So if I start over, second calc, number 5 is intersect. First curve stays, second curve stays, but this time, if I hit enter again, it's going to give me 0, 1 again. How do I get the other one? Arrow over to that spot. If I arrow over to that area and hit guess, now it tells me specifically that intersection point is 4, 5. So again, we use the second, whether you think of it as trace or calc. This time we used intersect from the menu. And we found the intersection points to be 0, 1 and 4, 5. Got the calculators flowing? Well, my hope was that, yes, it's been a while. It's been all summer. I mean, I didn't pick mine up all summer. And I'm better at it now, but after taking, the first year I used them and then sitting all summer, it was rough at the beginning of that second year using a graphing calculator because I didn't remember. So, you might try new calculators. Or new calculators.